chapter to cover, unit to cover. No, we will get to it, young lady. So here we go. Okay, now we're going to do limits. And what's going to happen on the bottom if I stick in a -5? I'm going to get 0 on the bottom. What's going to happen on the top if I put a -5 in? This is 250. This is -250. So I get 0 over 0. Now, if you say, well, we have 0 on the bottom, so the limit does not exist. Well, that would happen in make-believe and fairy tale land. But here, when 0 over 0, we have to find a way to reduce this. This it has a special name for it. It's indeterminate form. That's what it is. This is indeterminate form when you have 0 over 0, which means you can do something to this. So we go back to the start again and say, hey, I learned in Algebra 1 that we can factor. Let me take out a 10x out of here. And I get x plus 5. The denominator, how does it factor? Starts with a D. Difference of squares. There we go, Kate. Difference of squares. X minus 5, x plus 5, right? Well, now these cancel. So I'm really taking the limit as x approaches -5 of 10x over x minus 5. So if I plug in my -5 now, I get -50 over -10, which is +5. So if you get indeterminate form, that means you can probably factor or do something else, which we'll get to. Okay? So if we stick a -2 in here, we get -8 plus a +12 plus a -4 over -2 plus 2, which is 0 over 0 indeterminate form, correct? So we factor the top. Factor out an x first. You get x squared plus 3x plus 2. Now, if you're a smart person, which I think all of you in here are, you see an x plus 2 in the denominator. So what do you think one of the factors in the numerator will be? X plus 2. I'm glad the smart people answered. Oh, I got a phone call from x plus 1. Mr. Fox. Good. Say, did you ever make a commercial for our video board yet? Like a 30-second commercial? Okay, that's fine. So, okay. Yep. Nope. We'll just have your logo up there and stuff, and that's fine. So I would just wanted to, because I'm programming the whole football video board, and I thought, well, if you had one, then I'd throw it up there. So. Okay, that sounds good. All right, thank you. Bye. Okay. So, then what happens? The x plus 2's cancel. If we stick -2 in here, we get -2 times -2 plus 1, which is -2 times -1, which is a +2. How about this one? Well, we get -8 minus a -8 over 4 minus 4. Wait, it's regular 8. Yeah, Mr. Bierschbach can't do math. So it's regular 8 because it's a positive 2. I thought it was negative 2. So we get 0 over 0, and obviously that doesn't factor. Cancel. So if we take out an x squared, we get x minus 2. The denominator factors how? Difference of squares, x plus 2, x minus 2. X minus 2's cancel. We get 4 over 4, which is 1. Now, those of you who say, this is just too hard. Well, those of you who like to cheat your way around things, if you put this into your graphing calculator, you can check out the graph and trace to where 2 goes. Now, the graph will have a hole in it, so if you just trace to 2, it'll say does not exist, or it'll be empty. You have to go close from each way, because the graph will look kind of like this. And that's where 1 will be. It'll have a y value of 1. Okay? So these graphs will be graphs with holes in them. Okay? So that's what they'll look like. Now, if you have a square root function, okay? If you have a square root function, and if you put a negative 2 in here, I get the square root of negative 6 plus 10 minus 2 over negative 2 plus 2, which is the square root of 4 minus 2 over negative 2 plus 2, which is 2 minus 2, which is 0 over 0, indeterminate form, right? Okay, we can't factor that. But what can we do? Well, we can do kind of opposite of what we were told to do in Algebra 2. We had to rationalize the denominator in Algebra 2. When limits don't work, we have to rationalize wherever the square root is. So in this case, I'm going to rationalize the numerator. Sometimes we'll rationalize the numerator, sometimes we'll rationalize the denominator, but we'll take both the numerator and the denominator by what's in the numerator, except for opposite sign. So the square root of 3x plus 10 plus 2, both the numerator and denominator times that. Now, I'm not going to try to multiply through on the denominator. I'm just going to leave it separated. The numerator, first times first, is what you get under the parentheses. Outers and inners always, always, always what in conjugate pairs? Cancel. And then last times last would be negative 4. In my denominator, I'm just going to leave it the way it was here, because I don't want to try to multiply that. That's too complicated. That would take too much brain power, and I don't want to use a lot of brain power right now. So if you take negative 2 and stick it here, 3 times negative 2 plus 10 is what? That's negative 6 plus 10 is? It's 4. So you get 4 minus 4, so your numerator is 0. Let's see what the denominator becomes. Oh, shoot, it's 0. Uh-oh. Is it 0? It is 0. What did I do wrong, people? What did I do wrong? Oh, I do have to multiply this out. I'm sorry, I do have to multiply this out, I think. So 3x plus 10 minus 4 over, if we FOILed this, it's x times the square root of 3x plus 10 plus 2 times the square root of 3x plus 10 plus 2x plus 4. Because the numerator here is 3x plus 6 What is going on? There's something I'm missing. What am I doing wrong? Rationalize that. Because something's supposed to cancel with this x plus 2. Oh, it does cancel with the x. Mr. Bierschbach's having a total brain fart today. I was right the first time. You guys are losing a lot of your eraser because Mr. Bierschbach can't think. Okay, so we're there. Guess what we can do in the numerator? Factor out of 3 and we get x plus 2. Then our x plus 2's cancel. So then I get 3 over the square root of 3 times negative 2 plus 10 plus 2. So it's 3 over 4 plus 2, the square root of 4 plus 2, which is 3 over 4, which is 3/4. That was ugly. We'll do better this one. I'll do better. I promise. I'll do better on this one. I knew that's what we had to do, and I just didn't see it there for a second. Okay. So this time we have to rationalize the denominator. So x minus 3 and 2 minus the square root of x plus 1. And then 2 plus the square root of x plus 1. So leave the numerator separated. You don't have to try to multiply through by your square root in these problems because they made them so they will cancel for you. The denominator we FOIL. 2 times 2 is 4 minus, and whatever matches, x plus 1. So it's x minus 3 times 2 plus the square root of x plus 1. 4 minus 1 is 3, and then minus x. Now, do these match the top and the bottom to cancel? No. So the bottom, you have to take out a negative 1 to make it x minus 3, and then they match to cancel. So it's 2 plus the square root of 3 plus 1, because I'm sticking in the 3 from here, over negative 1. So it's 2 plus 2 over negative 1, or negative 4. Okay. Do it one more time, because we got better on that one. Last one of these. So we'll multiply top and bottom by 5 plus the square root of 3x plus 28. So my numerator will be 25 minus 3x plus 28. My denominator will keep separated as x plus 1, and 5 times 5 plus the square root of 3x plus 28. So my numerator is 25 minus 28, which is negative 3, and then minus 3x. Now, I want to cancel that x plus 1. How can I cancel out that x plus 1? What am I going to factor out on the top? Negative 3. 6 plus 1's cancel. I get negative 3 over 5 plus the square root of 3 times 1 plus 28 times negative 1 plus 28. So this is the square root of 25, which is 5. So it's negative 3 over 5 plus 5, or negative 3/10. Okay, trig. If you take 2 times pi plus 2, you get pi. So it's the sine of pi over the cosine of pi over 2, which is 0 over 0. That doesn't work out, right? And I'm sure you all remember your trig. What's the sine of 2x the same as? This was from like chapter 3 of trig. Well, the sine of 2x is 2 times the sine of x times the cosine of x, or the cosine of x. So what'll cancel? Cosine of x. So you're now taking 2 times the sine of pi over 2. What's the sine of pi over 2? Well, unit circle, that's right there. That's the point 0, 1, so the sine would be 1. 2 times 1 is 2. So one thing to write down, you need to remember that the sine of 2x is 2 times the sine of x times the cosine of x. That is a trig identity that you'll need to know. One minus cosine of x over 2 sine squared of x. Well, I know that sine squared of x plus cosine squared of x equals 1, right? That's one of my trig identities, my Pythagorean identities. So if I have sine squared of x equals 1 minus cosine squared of x. So I have 1 minus cosine of x over 2 times 1 minus cosine squared of x. If I put in 0, cosine of 0 is 1, so I get 0 over 0, so it won't work. Now, what can I do with this bottom here? What's 1 minus cosine squared? That can factor, right? How does that factor? Starts with a D. Difference of squares. 1 plus cosine of x, 1 minus cosine of x. Oh, they cancel. So I get 0 over 2 times 1 plus cosine of 0. What's the cosine of 0? Well, it's 1. So it's 0 over 2 times 2, which is 0 over 4, which is 0. So those trig identities that you learned whenever you took trig, those are important. The cosine of 2x. That equals cosine squared of, cosine squared of x minus 1. Is that? No. 2 cosine squared of x minus 1. That's what it is. 2 cosine squared of x minus 1. It also equals cosine squared of x minus sine squared of x. And it also equals 1 minus 2 sine squared of x. Those are the three trig identities for the cosine of 2x. Probably want to write those down, so those are handy somewhere. Now, when you see the cosine of 2x in the denominator here, and this in the numerator, which of these three do you think I should probably use? The first one, the second one, or the third one? Well, if I have 1 plus the square root of 2 sine of x, that looks like a lot like this, right? So I'm going to go 1 plus the square root of 2 sine of x. In the denominator, I'm going to have 1 minus 2 sine squared of x. And again, this is difference of squares on the bottom. It's 1 plus and 1 minus. And if you split up this, it's the square root of 2 sine of x and the square root of 2 sine of x. Well, if my numerator is 1 plus square root of 2 sine of x, they cancel. So I get 1 over 1 minus square root of 2 sine of x, which is negative pi over 4. Unit circle. Negative pi over 4 is 45 degrees down, which is square root of 2 over 2, square root of 2 over 2, right? Negative, positive, and negative. All right, so if we put that in, 1 over 1 minus square root of 2 times negative square root of 2 over 2, which is 1 over 1 minus square root of 2 times square root of 2 is 2, 2 over 2 is 1, so it's 1 minus a negative 1, which is 1 over 2, or 1 half. All right, there you go. So, making your brains hurt a little bit today. We're only going to do, I'm not going to, all right.